forecasting method of power consumption information for power users based on cloud computing. Chen and Yukun and Jiang Chao and Jingrui and Xiaowei. Abstract. In order to realize the real-time balance of power demand and effectively avoid the waste of power, it is necessary to forecast the power consumption. Under this background, a forecasting method of power consumption information for power users based on cloud computing is designed. The prediction model framework is designed based on cloud computing technology, carry out abnormal data processing, missing data filling, and normalization for power consumption data. Calculate the correlation degree and select the influencing factors of power consumption of power users, combined with multiple regression analysis. The forecasting model of electricity consumption information of power users is constructed. The results show that the mean absolute percentage error (max) introduction compared with other energy sources. Electric energy has the characteristics of balance of generation, transmission, and distribution, and difficulty in large-scale storage. In order to achieve the real-time balance of power demand and effectively avoid the waste of electric energy, short-term forecasting of power consumption is required. Short-term forecasting of power system energy can provide accurate data reference for market operation and the market planning of power system. However, the short-term power consumption forecasting of power system is a complex problem, which is mainly reflected in influenced by the type of power users. The fluctuation of power consumption is large and shows obvious predictability. Electricity consumption is affected by weather, holidays, economic conditions, and other factors, and its volatility is large. Prediction. Model of power consumption information for power users. Cloud computing is an effective way to process massive data proposed by the industry in recent years. 4. Cloud computing mainly includes 3 levels: infrastructure as a service, platform as a service, and software as a service. Generally, cloud computing should have the following characteristics: rapidly deploy resources or obtain services based on virtualization technology, realize dynamic and scalable expansion, provide the resources according to demand, and pay according to usage. It is provided through the Internet for massive information processing. Users can easily participate, flexible shape, free gathering, and dispersing. Reduce the processing burden of user terminals. It reduces users' dependence on IT expertise. The core of cloud computing is map or reduce technology. Methodologization. The data used in this paper is from the daily hourly electricity consumption data of California from February 6, 2017 to April 16, 2017. This group of data has 24 observations every day, and each group of observations covers 2 GB data. There are 480 GB observations in 10 weeks. In this paper, the data of 9 weeks from February 6, 2017 to April 9, 2017 are used to forecast the average hourly power consumption from April 10, 217 to April 16, 217. The fluctuation of the original power consumption date is shown in Fig. 1. Conclusion. In order to improve the applicability of power user power consumption information prediction, this paper proposes a cloud computing based power user power consumption information prediction method. In this paper, based on cloud computing technology, a power consumption information prediction method for power users is constructed. On this basis, the influencing factors of power consumption are analyzed. The experimental results show that the proposed method has good prediction accuracy. Reference. Sound real sound. Company rates multi-cognitive organization valued natural networks as they relate to time series analysis G 2020-31 to 539 to 548. September VE Shin Cancel CHO Yangmin efficient energy consumption prediction model for a date analytic enabled industry building in a smart city G building research and information 2021 49 127 to 143. Gates are MDV key, primary M, prediction of domestic power peak demand and consumption using supervised machine learning with smart meter that tested G. Multimedia tools and applications 2021 80 13 18675 to 18693 Blue Energy Timely CA Dynamic resource allocation with optimized task scheduling and improved power management in cloud computing G. Journal of Ambient Intelligence and Humanized Computing 2021 23 4147 to 4159. Thank you.